Sleep. Sleep is considered as loss of consciousness from which a person is wakened by means of an appropriate stimuli. A stimuli could be either the person is called, a call could be a stimuli, or light could be a stimuli, or your biological clock could be a stimuli. And if your fan is not working suddenly, again that might be an appropriate stimuli. So such stimuli, if you are awakened by such a stimuli from a state of loss of consciousness, then that is known as sleep. There are two types of sleep: slow wave sleep, which is also known as non-rapid eye movement. And if a person sleeps about 8 hours, 75% of his sleep time is occupied by this non-rapid eye movement sleep. 8 hours if he is sleeping, out of that 6 hours that is non-REM type. And it's a peaceful or a restful sleep wherein your body decreases its vascular tone, a decrease in blood pressure occurs, as well as your respiratory rate also decreases, the ventilation rate also decreases, which altogether brings a decrease in basal metabolic rate. And it is known as non-rapid eye movement because no rapid eye movement occurs during this type of sleep. And if you are sleeping in a non-REM, and if EEG is recorded, the waves that are recorded are theta as well as delta waves. And during the time of non-REM, dreams occur, but you are not able to recall or remember your dreams. Whatever dreams that occur, and if you are able to recall it, that occurs during rapid eye movement sleep, which is a second type of sleep, and which occurs in episodes of 5 to 10 minutes duration between these non-rapid eye movement sleep. And this occurs every 80 minutes. You get a 5 to 10 minutes of rapid eye movement, and it is called rapid eye movement because movement of eye takes place during this sleep. And if a person is tired, if a person is completely tired, the duration of REM is smaller, and the non-REM that increases. And if you have a dream during REM, you are able to recall that dream during your daytime. So whatever dream you are able to recollect, that occurs during rapid eye movement. And here also it's the same, there's a decrease in muscle tone just like non-REM sleep, and this is due to excitation of reticular inhibitory centers. There is rapid rolling movement of the eyes, and also erection of penis and engorgement of clitoris occurs during this stage of rapid eye movement. As well as twitches of facial and lip muscles also occur during this stage, and it is difficult to awake a person during rapid eye movement. Though your eyes may be moving rapidly, it is hard to awake a person who is having rapid eye movement. Though non-REM that looks peaceful, it's easy to awake a person who is in non-REM rather than rapid eye movement. And EEG records waves of B waves indicating a high level of activity in the brain during rapid eye movement. The respiratory as well as eye muscles are active during this stage of rapid eye movement, as well as your skeletal muscles. Those are bit decreased. They show a bit decreased activity during the rapid eye movement. And importance of rapid eye movement sleep, it's a subconscious one. Dreams occur, and whatever concerns you have in your that day or that particular week, maybe whatever lies subconsciousness, that may come into your conscious mind or as form of dream. There are long-term chemical and structural changes that occur during this stage of rapid eye movement, because whatever concerns are there, you are thinking about those concerns during sleep. And when you are thinking again, that is recalling, it is learning that occurs, and this learning that is stored as memory. And NREM sleep, that is divided into four stages. The stage first NREM, when a person is initially sleeping, the first sleep that occurs is stage 1 NREM, where it is low amplitude one, fast activity, and that is recorded as alpha waves by EEG. And usually it occurs somewhere about 1 to 7 minutes. When you sleep, suddenly you wake up, or you start to realize you are sleeping. And might be it takes about 1 to 7 minutes. You are falling asleep, you know the surroundings, but still you are in a stage of sleep. The second stage, or NREM1, that is the first stage of true sleep. It's marked by appearance of fragments of sleep, and these are bursts of alpha like 10 to 14 hertz, 10 to 14 hertz that occur during this second stage. The third stage NREM, lower frequency, mainly theta waves, are recorded during EEG, those that up to 20 minutes after falling asleep, that falls within the stage 3 NREM. And your temperature as well as blood pressure, your vascular activity, all this decreases, and this is a stage where it is difficult to awaken a person. And stage 4 NREM, still slower frequency, where it is mainly delta waves with higher amplitude waves that occur during stage 4 NREM. REM sleep, that is of low voltage but faster activity, and beta waves are recorded during REM sleep, or rapid eye movement sleep. So this is an EEG which shows the different stages, the stage 1, the stage 2, as well as the stage 3 and stage 4 of NREM, non-rapid eye movement sleep. How the waves of EEG, there's a difference in pattern from alpha to theta 1. And distribution of sleep stages, while NREM occupies 75 to 80%, it is interrupted by intervening rapid eye movement sleep periods every 80 to 90 minutes. And in a young adult, NREM occupies the 75 to 80% of a night's sleep time, and REM sleep occupies the rest of 20 to 25% sleep time. And in a typical night of sleep, a young adult first enters NREM sleep, passes through stage 1, 2, 3, and 4, and then he goes to first REM sleep episode. This cycle, that is repeated at intervals of about 80 to 90 minutes throughout the 8 hours or so of a night sleep. So therefore there are about 4 to 6 sleep cycles per night that occurs when a person sleeps for 8 hours. As the night goes on, there is a progressive reduction in stages 3 and 4 sleep, and a progressive increase in rapid eye movement sleep. That is why you are able to recollect whatever you are dreaming during the morning hours, because it is mostly the REM sleep that occurs. And for premature infants, REM sleep occupies 80% of total sleep time, and full-term neonates, 50% of sleep time is occupied by REM. As well as aged and elderly, the proportion of REM sleep falls rapidly at about 25% until it falls further in old age. Periods of sleep and wakefulness alternate about once a day, and it is a circadian rhythm, consists typically of 8 hours sleep and 16 hours awake, and this rhythm is controlled by the biological clock function of suprachiasmatic nucleus within the hypothalamus. It is not under our control, and the circadian rhythm, or the biological clock, controls all our activities. Within sleep portion of this circadian cycle, NREM and REM sleep also alternates. It is during, we are speaking about a normal condition. Adenosine sleep inducing factor, it accumulates in brain with prolonged wakefulness, and adenosine antagonists, example caffeine, that brings about alertness. The next topic is dream. Every person dreams, right? Uh, Whatever we dream during rapid eye movement, I told you, we are able to recollect. And whatever we are dreaming during non-REM stages, we are unable to recollect. There also dream occurs. Maybe it's mm, good ones, bad ones. Mostly it is bad ones that occur, because whatever concern is there, that is made into a picture, what we call as dreams. Dreams are succession of images, ideas, emotions and sensations occurring involuntarily in the mind during certain stages of sleep. Dreaming is the perceived experience of sensory images and sounds during sleeping, where the dreamer is a participant. And Sigmund Freud puts it, dreams are the symbolic expressions of frustrated desires that had been relegated to unconscious mind. Whatever is there within our unconscious or our subconscious mind, actually that comes out as dreams. And stimulated by pawns and during REM sleep lasts for few seconds to minutes. Scientific study of dreams, that is known as oneurology, and the hardest thing is 8 out of the 10 dreams that you dream are mainly negative. It's not about a person's negativity or positivity, but whatever concern we have, we mainly have concerns about something the bad that is going to happen, and these concerns come as dream. Why do we dream? Actually, we dream to satisfy our wishes or hidden manifestation. Whatever wishes that is left unfulfilled, or if a person is waiting for his exam result and he is thinking whether to get 90% or above 95%, then again that's a serious concern, but a wish to get the best. So that concern plus wish, that brings about a dream. So whenever there is some result or something coming, so you dream that day, that either it could be a fear that is coming as negative one, or a positive one. Whatever emotions are there, they come as a picture, and whatever picture that comes, that is recorded as memory. It develops and preserves neural pathways. Whatever concern is there, you recollect it. Once you recollect it, it's a process of learning as well as memory takes place, and memory means it is incorporated within your neural pathways. Dreams make sense of neural static to reflect cognitive development also. You dream. And Hobson's activation synthesis theory explains dream. During REM sleep, many brainstem circuits become active and bombard the cerebral cortex with neural signals. These signals actually they are converted as dream. And the forebrain, whatever concerns are there, maybe it's all those concerns are unrelated ones, but the forebrain attempts to place meaning on the random signals created from the activation of brainstem, resulting in coherent dreams. So whatever you think about, that is made into a story. Those come as images, it is made into story, and your limbic system is part of this dream. So it creates abstract imagery during dreaming. Next is learning. Learning is acquiring new or modifying existing knowledge, behavior, skills, values, or preferences. Human learning occurs as part of education, personal development, schooling, or training. We consider learning as part of education where a complete development of a person takes place in schooling. Out of schooling also learning takes place. Of learning, actually what occurs is you are recollecting and storing all informations. You are recollecting and storing all informations. The number of times you start to learn something, your nervous system stores that information as chemical constituents. Memory. Memory is the process by which information and experience acquired by learning is stored, retained, and recalled. So, learning and memory goes hand in hand. Habit memory, the part of memory which is recalled and used automatically, unconsciously for few seconds, like use of calculator. Reflexive memory, athletic skills, driving skills, those all are reflexive memory. And declarative memory, those are recalled by conscious effort, and it is divided into two: short term memory, long term memory. Some things that you learn you remember throughout your life, and something you learn that is just meant for exam point of view. You learn, the next day you write it, and the other day you just forget it. So those are included in short term memory. Once a person tells his name, his mobile number, maybe he is saying his mobile number, you chant it for some 2 to 3 times, it is by heart. But the next day maybe you are unable to recollect it, that is short term memory. But if you are able to recollect it next day, and you keep on recollecting it, that results in what is known as long term memory. The frontal, the parietal, occipital, and temporal lobes, parts of the limbic system, hippocampus, amygdala, and diencephalon, these are the areas that is concerned with learning as well as memory. Short-term memory include recalling numbers, names immediately after exposure to such information, and those are associated with presynaptic facilitations, which involves slow and prolonged action potentials and open of calcium channels for longer periods. The hippocampus, mammillary bodies, two nuclei of the thalamus, those are concerned with short-term memory. And the amount of short-term memory that a person is able to store, that depends on each individual. And usually short-term memory is dependent on electrical and chemical changes than structural changes, whereas long-term memory, physical and chemical LTM, it is LTM, physical and chemical changes occur in neuron, because every time when you are recollecting it, it is chemical changes that occur. So by thereby it is being converted into long-term memory. Increase in number of synaptical terminals and increase in thickness in postsynaptic membrane occurs during long-term memory. Repetition, number of terminals increases with frequency of sensory process. Every time when you repeat something, the number of synaptic terminals also increases with frequency of sensory process. Thereby the short-term memory, or whatever you want to convert to long-term memory, is being converted to long-term memory. Memory consolidation, the reinforcement that results from frequent retrieval of a piece of information. Every time, usually bad things that that remains for a longer time, because most of the time you try to recollect it. You try to recollect it, the more it gets stored in your brain. Plasticity, for an experience to become part of memory, it must produce persistent structural and functional changes that represent experience in brain. And this brings about structural changes within the neuron, and this results in long-term memory. This capability for change associated with learning is called plasticity.